Good morning, good afternoon, wherever you are in your day. Welcome to what in all likelihood will be the final lesson for Algebra 1 and Informal Geometry for Petoskey High School in the spring of 2020. There may be some stuff coming out, and in all likelihood, this will be the last one. The other ones will be more to encourage you to continue to explore and develop your skills and preview next year's course. Play with different content that has mathematics in it. So without further ado, let's do a little screen sharing. And let's present this to you. Okay, so as previously stated, we are looking at this being the last formal lesson. Like I said before, there could be something coming out next week. But this is in all likelihood, like 95% likelihood, everything that's going to be up and up is on YouTube, and everything that's going to be assigned to you has been assigned to you. Because where we're going with the last and final week is just to encourage you to keep chipping away and really to keep it up over the summer. So, work on old concepts that are a challenge. I've never really, figured out fractions. Pull that up and work on that. That's not going to hurt you. In fact, mastery of those basic algebra concepts are really going to help students looking to go to college. That's one of the takeaways from some research that I read about what college professors are looking for regarding mathematics. Is a really solid handle on foundations, fractions, solving equations, factoring, stuff like that. Really rock solid with that will help you at the next level if you're planning to go there, and if you're not, no worries. Maybe preview next year's course. If you're going into geometry, hop on the geometry, try some of that. And if you don't get it, no worries. Early exposure, call that pre-teaching, will help you achieve further down the line, right? And play, encourage you to play. There's some computer programming stuff on there that I've done in the past, and I have my children do. That's great. There's math and economics. Try some of that out. There's math and physics is really applied mathematics. So jump on there and try some of that. So kind of any topic that has some math in it, you want to kind of muck around in there and see what you can learn, great. And if it's a challenge, no worries. It's not going to hurt you in the long run. In fact, it might help inform some of your decisions. So, last formal lesson here, but encourage you strongly to keep chipping away, whether it's old stuff that's been a challenge, new stuff where you're going, something you're interested in, all that will benefit you down the road. So with that being said, let's look at some informal geometry examples. So here is informal geometry examples. So we're looking at parallel and perpendicular. Okay, so maybe I should draw a couple of those. So parallel lines, such as that. I'll try and get it. Parallel lines never intersect and have same slope. And M is generally our abbreviation for slopes. And never intersects probably not the best thing to say. They never intersect unless they're the same line. So it's possible that they could be read on top of each other, and then they would always intersect. So same slope is the big takeaway. And then, generally they will never intersect. Sometimes they're the same line. So in that case, they'll always intersect. All right, so that is parallel perpendicular. Let us look at some perpendicular. Perpendicular, 90 degrees. Try and get a representation close enough. We'll say that. Make that a right angle. There we go. So 90 degrees, perpendicular lines. Those have opposite reciprocal slopes. So and opposite is just opposite sign. So if it's positive, it's a negative. If it's the negative, positive. Reciprocal is just flip it over. So numerator becomes the denominator. Denominator becomes the numerator. Top becomes the bottom. Bottom becomes the top. However you want to think about it. So I'll give you a couple examples so you can see that. Let's see if we had a slope of like 3. The opposite of reciprocal of 3 would be negative 1/3. Positive becomes a negative, and then 3 is the same as 3/1, so you just flip it. So let's say we had something like negative 2/7. So that would flip to be positive 7/2. Okay, so there's a couple examples of opposite reciprocal slopes. So we're going to be generally given some line, some point. Got to find the slope. Keep it the same if it's parallel. Flip it, change the sign if it's perpendicular, and then put it through some other point. Generally, how these proceed. All right, so here's some examples from the work packet that I sent home to students. So this one is through 2, and it's parallel to this line. So the slope of this line right there is 1, because there is a 1. Number students call it a ghost. A ghost 1 hanging out in front of that. So the slope of this line is 1. Our new line is going to be parallel to that, so the slope is the same. It's also going to be 1. And then I'm using, this is called the point slope equation, which is this in general. Y minus y1 is m x minus x. Okay, so it's just plug and chug. You've got a point, you got a slope, just throw it in there and simplify it. So putting 2 in for y. This is like x1, and this is like y1. And then we're plugging in 2 for x1, plugging in 1 for m, and then it's just simplify it. Distribute the 1, that's not going to change anything. Add the 2 each side. Final answer in this case would be y equals x. So there's one example of a parallel line through So then there's perpendicular. There's a perpendicular example as well. So we're going through this point this time. So go ahead, label x1, y1. The slope of this line is again 1. This time we want a perpendicular line to that. So we need the opposite reciprocal of 1. So if m in this line is 1, the opposite reciprocal of 1 is -1/1 or just -1. So right there. So same kind of thing we did in example 1. There's that point slope equation. I'm going to plug -1 in for m. I'm going to plug 4 in for x1, and then -1 in for y1. Minus becomes a plus. So then again, it's just simplifying, distributing -1 here. Minus x plus 4, and then subtract the 1. -x plus 3. So there's an example of finding a line parallel to another line to a certain point, and a line perpendicular to a certain line to another point. So I hope that helps. No worries if it doesn't. There's help. I'm available for help. There's help online. There's help in class. So let's pull that down. So equation of the line parallel to y equals 9 that passes through this point. So for this, I actually like to use the picture here. So let's get some kind of axis going. Now, one strategy that you can use, you don't have to, is just to make a table. X and Y. So here's X and Y. This equation right here says that Y is always 9. So I'm just going to take 9 and put it in here. You can do it as many times as you want. You need at least 2 points for line. And then I'm picking x's, and I'm picking my favorite numbers, 0 and 1. And if you want to pick another one, pick another one. That's enough. And I would make it easy on myself. Some students like to, air it out and make it all kinds of challenging. So they might pick like 1 billion, or let's say 10,000. But you can put whatever you want. I would pick 2, but whatever. So so then where is the point 0, 9? Well, it's right there. Where is the point 1, 9? It's right there. Where's the point 10,000? It's somewhere out here. What? Okay. The point remains that this line is a horizontal line through 9. So then we need a line parallel to that, so we need another horizontal line. But it needs to go through this point right here. So where is this point right here? 3, -8. So it's down here. So this line will look like, if it's parallel to that, it's going to be down here, and it's going to go through that point, and it's going to be horizontal. That might not be perfect, but it serves the ends of this problem. So so then what would the equation of this line be? Well, if this line is y equals 9, This line is going to be y equals -8. So a little different look, different strategies, drawing a picture, great problem solving strategy. Use it all the time, especially around the house building some boxes for our garden. Start by drawing a picture, right? You know how much lumber you need, what you need to do, have a plan, great problem solving strategy. All right, so let's clear that. Let's look at another example. Equation of the line perpendicular. So now we need perpendicular. So the slope of this one is -1. It says it's perpendicular, so we need the opposite reciprocal. So then that would go to +1. So I'll put m new equals +1. So then I got points, I got a slope, and I'm gonna rock and roll. So y minus y1 equals m x minus x1. So there we are. And then it's just plug and chug. This is x1. This is y1. And there's our new m. So let's just throw that in there and go to work on this guy. So if I throw this in here, let's go y plus 4 equals 1, x plus 9. Straight to 1, y plus 4 equals x plus 9. Track the 5. And y equals x plus 5. Final answer right there. There you go. All right, so another example of how to do these parallel and perpendicular line problems. Okay, so that being said, let's look at some algebra examples. Okay, so just a couple examples from the work, the hard copy work sent home. So we're solving these radical equations. So generally want to isolate the radical and then square both sides and then solve. So because the radical is isolated on the left-hand side here, it's all by itself. I'm just going to square it. And squaring a square root, those are inverse operations, so they just cancel each other, those operations. So 2 minus y equals y squared is y squared. To solve second degree polynomials. We want to set them equal to 0. So I subtracted 2 and added y to keep the y squared positive. You could do it the other way if you want. No worries. So I got 0 is y squared plus y minus 2. Factor, diamond, a is 1. You can use the shortcut. So what multiplies to get -2, that adds to get +1. So 2 and -1. Factor it, equal to 0. Solve them. 0 product property, set each piece equal to 0. Solve it. Y is 1, y is -2. Let's talk extraneous solutions. So it's possible that you can get extraneous or extra solutions. So you do need to plug it back in and make sure it works. So if you plug 1 back in, you get 1 is 1, which works. If you plug -2 in, you get 2 is -2, which is not true. So that is out. So make sure you're plugging things back in and getting it to work. Let's look at another one. So as I said to start this, basically want to get that radical of the root by itself. So I'm going to subtract 3. I guess I wrote minus x, but definitely subtract 3. So x minus 3 right there. Now those are by themselves, that root is. So I'm going to square it. Okay, so when I square a radical, I get what was under the radical. And then over here, you could write it twice and FOIL it. It's just squaring this binomial, so you can use perfect square pattern. X squared minus 6x plus 9. Same thing we did over here. Set it equal to 0. So subtract x, add 1. So now I've got x squared minus 7x plus 10 is 0. There's my diamond. Factor this second degree polynomial. X minus 5, x minus 2. Both those pieces need to equal 0 or can equal 0 to get you 0. So solve. I get x is 5 and x equals 2. Plug it back in and you will see that 2 does not work. So if we plug 2 in here, we get 1. 2 minus 1 is 1. Further 1 is 1. 1 plus 3 equals 2. Obviously, there's an issue with that. So make sure you plug them back in and make sure they check. 5 works. So 5 minus 1 is 4. Root of 4 is 2. 2 plus 3 is 5. 5 would work. 2 would give you a problem. So make sure you plug it back in to check. All right, so let's look at one from the homework. So here we go. So this radical is all by itself, so I'm going to proceed right into the square. Thou shalt do it to one side, thou shalt do it to the other. And then that just gets rid of the radical. And then perfect square pattern. I'm just going to imagine those are written the other way because it doesn't matter. Usually you'd be more familiar with that. And then we'll have it in descending order. So if I squared that, I get w squared plus 26w plus 13 squared, which is 160. All right, so now we're here. I want to set it equal to 0. So I'm going to subtract 8 and add a 4w. And if thou shalt do it to one side, thou shalt do it to the other. And then our new line would be 0 equals w squared plus 30w plus 61. Okay, so second degree polynomial, trinomial with a 1, use diamond, use shortcut, and yeah, see what works. So 161 and 30. So, you know, as honest as I can be, I had to get my calculator out, and you know, I know 1 goes into 161, but it's not going to 30. There's 2 go, no, 3 go, 4 go, 5 go, 6 go. I just got my calculator out and trial and error. Because I didn't know the factors of 161. No shame in that. So I kept going through, and then I found that 7 goes in, and it goes in 23. So because A is 1, I can now diamond. W plus 7. And W plus 23. So that each one of those pieces equal to 0. So I'll just throw another equal 0 over here. And then solve each one of those chunks. So W is going to be, W is -7. And W is -22. And then check them and plug them back in. And when I plugged them back in, I found that -23 was extraneous, did not work. So I crossed that one off and put -7 back in, and that one worked. So this was my answer. So there you go. That's how to solve these rational equations. So I hope that helps, and reach out if it doesn't. Keep chipping away, do the best you can, use the hints on com. You get frustrated, walk away, come back to it, try something else, come back another day. So the key is just to keep incrementally getting better. So let's kill the screen share here. Yeah, just say thanks for your efforts and have a great summer. There might be a video or two up, but really the key is just keep working on it. You know, in our family, we're just gonna keep addressing the old skills and the new skills. And, you know, I'm not gonna do it 8 hours a day every day over the summer, but work on it here and there a little bit. We will be in a better spot at the end of summer than where we are right now. Really, that's what we're looking for. So yeah, reach out if there's anything I can do to help. Be well, stay healthy, and enjoy your